Hi, because we're all kind of locked in, I figure I'd do another science experiment for you. Go around and you find whatever batteries you have. I have these 9-volt batteries, which are pretty good if you use other batteries as well. And I found a bunch of lights, and these are old holiday lights. And what I did was I stripped off some of the plastic on the very ends, and I expose the copper. And the copper, as we would call it, would be the conductor, and the rubber or the plastic is the insulator. And these lights work. There's a tiny little wire inside. When it gets the electricity flowing, it'll get orange hot, and this will glow kind of white reddish, right? And there we go. So that kind of works, and you can make circuits with these. Now, for my workshops, I use a whole bunch of what I call jumper wires. I have wires with little alligator clips. I just have a whole bunch, so I'm just going to use them. And then I went to the hardware store, and I bought a bunch of extra wire. This is the cheapest wire they have. This is called bell wire. It used to be used to wire up doorbells. And I have a circle full of bell wire, and then here I have a compass with a little needle, okay? So we know the battery works, right? It just lit up the light bulb, all right? And I happen to have another battery right here, and I have little jumpers on it. And I'm gonna make electricity in a moment, go through that coil of wire, okay? Now, let's think about what might happen when you put electricity through a coil of wire. What do you get? Let's see. So I'll put it through here. Oh, the needle just moved down. You might hear that, okay? And then I can move it around, and I get the needle moving. Now, it's not like I have a magic touch. I'm making a magnetic field. So electricity through a coil of wire generates a magnetic field. That's pretty cool. So I'm going to use that idea for some other things, all right? So I happen to have with me some straws lying around, and I took some of that wire and I wrapped it around a straw. Now I took the insulation off either end of the wire, okay? So now I'm going to use this, okay? That's my battery. And hook up to the wire around the straw and see what we might get. There's one. Oh, this is like pretty small. I need probably a little fatter thing here, but that's okay. We're improvising. This is a live video. And we get a needle to follow it. Pretty cool. So we're actually making an electromagnet right here. Magnetic field. It's moving around based on how, it came loose. That's why it wasn't as good. Here we go. Perfect. But that should work a little bit better. All right, now I also went to the hardware store and I bought some steel wire. This is meant to fix up fences, like fencing. And I cut a piece of steel wire, this big, okay? And now I'm gonna put it through my straw, okay? So it sticks out either end. I'm gonna hook up my straw to my battery source, okay? Hopefully this time it'll actually stay on. So I apologize for that last one. Here we go. Looks like that's gonna stay on. Oh, this white one was my one that I had problems with. Here we go. Perfect, good. So now I can go around and I can actually get the things to really move, spin around. Wow. It's pretty cool. So we're making a magnet. And we're making a much stronger magnet with steel inside, or iron core. Iron's actually the big key here. I put it over here, and actually the other side of the compass tracks here. And over here, I'll get the blue side of the track. Did you notice that? Blue side here, and now it's the non-blue side with this one. Wow. So let's see if we can take it yet another step. So I happen to have with me a motor over here, and this is called a St. Louis style motor. And the first thing you're going to notice is that there's two permanent magnets here. So I have North Pole and a South Pole, so they attract each other. And over here, we have two coils of wire. See if I can point. We have a coil of wire here, coil of wire here. And if you look really closely in the center, there's a piece of metal here, but it doesn't go all the way through. Right here, what I'm trying to look at. There's a split. It's called a split ring. Right here, this little spindle right here, it's in a split ring. These are the arms. Here, I'll move one of the brushes away. There you go. And see if you can see there's a split in there. Right, yeah, you can see the split there. So it doesn't connect all the way through, all right? And that's a key part. So basically, I'm gonna hook this up to my battery, okay? And we're gonna put electricity through this, and we have a piece of steel right here. So we're gonna make a sort of a powerful magnet. And I have permanent magnets here. And what happens is if you have a North Pole here and North Pole here, these are gonna push away and repel. If you have a South Pole here, South Pole here, these are gonna push away. Now it turns out there's a split, because what happens is every half turn, electricity can go the opposite direction. When it goes the opposite direction, it makes an opposite pole of the magnet. And so maybe this thing will keep spinning around. So I have a battery source. I need a little bit more juice than just lighting a light bulb. So I put two of them together, kind of like this. It's a little trick. There you go. So I kind of made a almost like an 18-volt battery right here. And I'll hook up one end here. And then the other end right here. See if I can get this. Oh, I heard it kind of, and now it's spinning. Kind of fun. Now if I take out a magnet, it's going to go slow and stop. So it needs another magnet to push away from it. So we made an electromagnet pushing away from the permanent magnets. And that's kind of a premise of electrical motors. And this is specifically the premise of the St. Louis style electric motor. And that's what this is called. Now, let's try to do something else with it. All right, we'll just connect that. I have a hand crank generator. And you do this, you're supposed to generate electricity, okay? So let's hook up my generator into an electric source. So I'll hook up here to this end right here. And here to this end right here. Let's see if I got it right. Oh, I had the red part come off, sorry. See, it's going around pretty fast. Now we'll say this going across this direction, right? Now I'm going to change the leads. Yellow over here, red over here. Hook it up. And notice it's going the opposite direction. That's right, because it depends on the direction of electricity. You know, you have a North Pole or a South Pole. And that's a kind of a fun thing that we can do. And if you have batteries lying around the house, wires and holiday lights, and you have straws, you can make electromagnets, and you use these to pick up paper clips. It's kind of fun. If you happen to have a compass, you get the compass needle to turn around, and it's kind of fun. Just a little bit of fun with electricity today. Hope you enjoy. Bye-bye.